All right, let's finish out the lab session here today with the last lab module we'll go through just for this session of optimizing a cube's performance. And as I mentioned earlier, the other two sections, if there's interest in those sections, maybe we'll schedule a future follow-up for that. Okay. All right. So optimizing a cube's performance. There's going to be 4 parts to this, and again, I'll introduce those 4 main ideas first, and then we'll dive into the hands-on portion. Well, not really hands-on, but I'll be showing you do a little show and tell of going through a demonstration of those 4 topics. Okay, so really query performance is mostly determined by basically how much data is already fetched from the database and in our caches, and how much information the report is actually trying to show to the user. In general, when you're querying against very large data warehouses, use of context filters and other types of filters to constrain the data that's processed is really expected, or it's a general expectation that a lot of the queries, OLAP-style queries and reports that are run against the dynamic cubes are at high levels of aggregation for those hierarchies. For example, you would do reports based off of profit for retailers in a region or products at a product line level, and then kind of drill down specifically on the areas that you want to get more detail. So you're actually drilling down filtered based on specific parameters, as opposed to a big, broad report that's at the lowest level of all these large dimensions. As you might have remembered from last year's lab, and if you didn't remember, you can always take a look at last year's lab that's out on YouTube. The link is shown earlier here, and also it's a URL shortcut. You can go to ibm.biz/dynamic cubes lab number 2, and that will go through steps of optimizing the cube. So we've always been talking about aggregates and in-memory aggregates and caches and all that. So really the use of aggregates, even in your database too, aggregates can really significantly improve the performance of your queries by providing data that is aggregated at higher levels than down at that lowest grain of the facts. Database aggregate tables, for example, are in your data warehouse, and they contain pre-computed data values and can really help boost query performance because it reduces the number of database rows that are processed for that SQL query that goes down to the database. But because not all relational databases out there have built-in aggregate support like DB2 has MQTs, Oracle has materialized views, and so forth, or even if they do have this built-in support to route to built-in aggregates in the database, some don't do it quite so well for the types of queries that we generate. So really Dynamic Cubes, one of the big features of Dynamic Cubes is our aggregate awareness and our ability to route these queries to the appropriate database aggregates or the fact table or what have you. So we really are bringing that logic up from the database optimizer up into the query engine, where we know how to best interpret multidimensional OLAP style kind of context and do that routing to the aggregates and guarantee that routing to the appropriate aggregates. So in addition to some of the guaranteed routing to aggregates in the database, big performance feature of Dynamic Cubes, we've been talking about it since the beginning, is our in-memory aggregates, right? So not only are in-memory aggregates, just have pre-computed data in memory, but they greatly improve query performance because of the aggregate data stored in memory is in the caches, ripe and ready to go. So, if you do have a warehouse that doesn't have any aggregates yet, or you want to supplement any existing database aggregates you might have with, some in-memory aggregates or maybe some additional database aggregates, you would run the Aggregate Advisor as part of your optimization workflow to get those recommendations for those aggregates, both, in-memory ones as well as your database ones. And so, really, best practice, easiest way to get any aggregates to, really boost your query performance is to run the Aggregate Advisor. Okay. And I'll go through a quick version of going through the advisor and the steps you would go through. In addition to having aggregates, so what I consider having in-memory aggregates and things as kind of preloading a subset of the data into the caches. What you can also do is prime the caches with a set of data as well. So cache priming involves running a set of reports to populate various caches like the result set cache, expression cache, and data cache. Additionally, accelerate the query performance of those reports. You can use this technique to optimize specific reports, especially if those reports that you have, kind of compute values, lots of specific values, or it might be more efficient to cache certain parts of information in a targeted way instead of having a very, very large aggregate. So I'll have an example of that here in the lab later on too. So a lot of these reports that you might want to use for cache priming, they might be stuff that comes from a set of dashboards or reports that your executives use or a majority of your users will use. So you might want to set those up to run right after the cube starts up and the in-memory aggregates load, so that they're ready by the time those people get into the office and run those reports for the first time in the morning. So, depending on the nature of those reports, you might want to, set up these primary reports to run after cube startup, or, after in-memory aggregates have completed loading. So, what's new coming out in 10.2.2 is the ability to identify a trigger for after in-memory aggregates have done loading. And this is really what we feel is a much better place and time to run these primary reports, so that you can take the most advantage of everything that's already in the caches in the in-memory aggregate cache. Okay, so I'll show you how to do that here in the lab in a little bit. The next area that we're going to cover today is a new feature in 10.2.2, our user-defined in-memory aggregates. And so really, this feature gives an advanced user, an advanced modeler, the ability to suggest in-memory aggregates to be included as part of the Aggregate Advisor recommendations. So some of these user-defined in-memory aggregates might reduce the overall time it takes to optimize dynamic cubes, because if you remember from running the Aggregate Advisor, it can take a little bit of time to go through the workload, analyze the slice cardinalities, and analyze the model, and come up with a full set of recommendations for aggregates. So if you know your users, you know the data, and you understand what aggregates you might need and want, you can define these here in your model. But do keep in mind, though, these will be in-memory aggregates, and so that might affect your performance and kind of memory utilization of the dynamic cube that's going to be in the aggregate cache. So as a best practice, we'd say that you should really continue running the Aggregate Advisor to get your recommendations for defining any of your in-memory aggregates. And another best practice is to have database aggregates that support those any and all in-memory aggregates out there. So including and especially user-defined ones to aid in the load time for those in-memory aggregates. Also, the last best practice I'll say here is that if you have any user-defined in-memory aggregates that are particularly deep in terms of the slice of levels that are there, like really, really deep, we really recommend that you'd also define some higher kind of intermediate level user-defined slices, and that's really just to aid in roll-ups, so you don't have to roll up all the way from the bottom. You can take advantage of some intermediate level ones as well. I think Dave might have mentioned this in the morning session as well. You do, and we'll go through this in the lab. After you publish your cube with the user-defined in-memory aggregates in the model into the content store, we'll still go through the Aggregate Advisor in DQA, and there you can work with, amalgamate, put together the set of in-memory aggregates you might want to assign to your cube, or I should say associate with your cube. Last task that we'll do today as part of optimizing the cube is going through some of the performance warnings you might see in Cube Designer. I don't know if you've noticed on the right-hand side there's a performance issues tab, and these are really kind of just warnings just meant to kind of alert you to any issues that you might have room for improvement. They're not errors. They're not going to keep you from, publishing your cube or anything like that. But they're just common scenarios and common things that you might want to take a second look at that might improve your performance of your cube, because the cube model is really the basis for all SQL that's generated out of the Dynamic Cube engine. So really, as a best practice, you should optimize your model really before doing any kind of heavy lifting with your database tuning or creating database aggregates, or in-memory aggregates, or any of that stuff. Because I don't know, I feel that the cube model and optimize your model is a very important and kind of overlooked area of cube performance. So a little later in this lab, we'll take a look at a couple of the common performance warnings you may encounter and how you could possibly remedy some of those things so you can get some better SQL out of your Dynamic Cube. Okay? All right, let's get in it. So we are going to talk about the Aggregate Advisor workflow. And I'm not going to cover all the nitty-gritty details like we did in last year's lab. So if you're interested in seeing the entire workflow from end to end, running the advisor and all that good stuff, take a look at the video that's already out there. It is on YouTube as well. So the link, we'll provide you that link, ibm.biz, Dynamic Cubes Lab, number 2. But I will just kind of go through a high-level refresher memory a little bit and we'll call out some of the new and cool features that are in DQA and the Aggregate Advisor. So some steps to do before you actually run the advisor workflow. I'd say, this is Avery's opinion, but maybe it'll be a real recommendation going forward. But first things first, it's probably a good idea to take a look at your hardware estimates, right? Because we want to take a look at how much memory do we suggest that you give your in-memory aggregate cache, right? So here, actually, what cube do I want to open? Let's open up our name sets cube that we finished off with last time. This is where we left off, estimate hardware sizing. And click on retrieve values from this cube. Because I don't think we did this just yet for the historic sales cube. We did it for the big time, as well as the filtered time one, but not just yet for historic sales. So let's just take a quick look at what the estimated hardware requirements are for a cube like this, and assuming the database that we're connected to is what we're going to be reporting on. We're going to use those sizes that come back as part of the queries that are happening right now in the background. It's doing those level member count queries for each of the dimensions and levels to get the count of members that are in your cube, as well as taking a look at your model to see what how many attributes are referenced there. We're going to keep the defaults for all users. We're going to say about 100, and let's just keep it at 1, the default for number of widgets per workspace. So in our historic sales cube, it's going to be about 4,025 members, 2 attributes. It's recommending about 26 megs for the JVM, and about 3 megs for the aggregate cache, for the in-memory aggregates. Okay, so let's just keep those numbers in mind. 3 megs, it's tiny, not a big deal. Okay, but really, my opinion, I think that's probably the best good first step that you would do, before running any of this optimization or Aggregate Advisor workflow, is finding out how much memory what's the minimum amount of memory I should give my aggregates. Really make sure that the cube is out there and ready to go. Select all options. Okay, let's start the cube up. So as part of the regular Aggregate Advisor workflow, I would say we would enable workload logging so that the query engine captures the workload, captures all the queries that are run by users, or maybe a set of reports that you run that you think are a representative set of reports that users would run as kind of input or training to the Aggregate Advisor. So let me just show you real quick where that is and how to find it. So let's go back here into Cognos Administration under Historic Sales Cube. That's the cube we're working with. Here to set properties. There is an option here to enable workload logging. What you would do is check that box, click OK to enable workload logging, and you're good to go. Note here that by default, the maximum space for in-memory aggregates is 0. That's okay for now. I mean, we don't know how much memory we want to give to it, but we have an idea of the minimum amount, right? We want at least 3 megs, but we'll just leave it 0 for now. So I'm just going to go real quick high level through the idea of the workload Aggregate Advisor workflow. So yeah, you turn on workload logging, click OK here, all good. You know, in previous versions of Dynamic Cubes, you would actually have to, click OK and then restart the cube for it to pick up the changed properties here. But new in 10.2.1 Fixed Pack 3 and later, it's not required anymore to restart the cube to enable workload logging. So you can enable and disable workload logging from these cube properties here as part of, even if your cube's running. It takes about 30 seconds, approximately 30 seconds, for the refresh of the properties to happen and take effect in the running cube. So that's one time saver as part of the workflow that we've enhanced here. But it is worth noting, though, that all the other properties here, they do require you to restart the cube to take effect. So if you change the size of your caches or what have you, you do still have to restart your cube. But if you just want to enable and disable workload logging, you don't have to restart your cube anymore. Just wait 30 seconds and you're good to go. I'm going to click OK. Let's assume I waited 30 seconds here, and I've run my reports. So if you remember from last year's lab, we had a bunch of reports here, 3 really, reports that we wanted to kind of capture as part of this quote-unquote representative workload. We have a report on region or product brand by year, month, year, product line, and promotions region by quarter. I'm not going to run them right now. Let's assume we already did. Just wanted to show you an accelerated version of that workflow. So then after you run your reports, then you would go into Dynamic Query Analyzer, which is where you would run the Aggregate Advisor. So all programs. And actually, while that's running, I want to point out something kind of cool. New in 10.2.2, 64-bit. There is now going to be a 64-bit version of Cube Designer. Previously, we only had Cube Designer as a 32-bit Windows application, also now 64-bit. So really just eases your installation and maintenance and all that. All your client tooling can be 64-bit Windows applications. So that's pretty cool. So what you'll see here, this is something a little bit new. New in 10.2.1 Fixed Pack 3. All the Aggregate Advisor results are now stored on the Cognos BI server instead of on the client workstation where you're running DQA or running Dynamic Query Analyzer. So the benefit of that is that you don't need to keep DQA open after starting an Aggregate Advisor run anymore. So previously you would start the run, you have to watch it, keep going. But now you can start an Aggregate Advisor run, shut down DQA application, start up the application later, and it'll retrieve the results from the server side and show you the results of your Aggregate Advisor run. Okay, so notice here on the left-hand side are a set of is the aggregate results view, and you'll see a bunch of the results from previous runs that I did, including ones from last year. And really what's shown here is just a simplified view, so you can quickly compare the summary information for all the different results. And there is now a refresh button here, so you can refresh and obtain results from the server side. Yes, so running the advisor, click on the shortcut, go to File, run Aggregate Advisor. First select your cube. Next, on this next page, General Options. In last year's lab, I would say to choose Query Workload Information Only. That's a quick way to get some advisor recommendations based on the workload that was captured here. run, and then next finished. And click on next. It will retrieve some of that workload information where you can filter it down a little bit more if you want, based off of time or users or package or what have you. So you can go through that, click finish, and it'll run the advisor. I'm not going to do that today. I'm going to use the pre-baked, done ahead of time version from last year. So this one last year, and incidentally, it's the same results you would get this year too. So I just want to quickly highlight some of the things you'll see here in the Aggregate Advisor recommendations. So you'll see here it recommended one in-database recommendation, one table at the product brand, promotion name, region by day, to get the information about that in-database aggregate. You can click here on the in-database tab. It's more textual information about that and some information about what this database aggregate contains, how many in-memory aggregates this database aggregate can cover, which is super helpful for load times of your in-memory aggregates, estimated row counts, and a sample SQL to use to load when you create your database aggregate. Okay. Going back to the general tab, it also recommended 4 in-memory aggregates and estimated the size for all 4 of these to be about a little shy of 2 megs, so not too bad, right? And our estimate when we did the sizing calculator was about 3, estimated that it needs about 2. I think we're in the same ballpark. It's not a big deal. Next step as part of the workflow is to kind of save your database in-database recommendations to a file. This file with the in-database information and the SQL and all that, you would then give that to your DBA to facilitate creating those aggregate tables for you, and then they would let you know and you'd continue on with the workflow. One thing I'll mention here is that in, I think it was 10.2.1 Fixpack 3, a bunch of the advisor heuristics have been improved a lot, and we do try to recommend database aggregates that will support the loading of in-memory aggregates as much as possible. So you may get more or better in-database recommendations that will support the loading of in-memory aggregates. So this would drastically really help reduce the time of loading those in-memory aggregates when you implement those recommended database aggregates too. So let's assume I saved that file, I gave it to my DBA, they've already created the database aggregate. What we can do next is apply a set of in-memory aggregates to my cube to load after cube startup time. So I've selected to apply in-memory recommendations. Here, now more of a tabular view, so for those folks that haven't seen this workflow in a long time, I think it was new in 10.2.1, Fixpack 1, you can pick and choose individual in-memory aggregates that you want as part of that set or not. I think previously in 10.2, when we first came out, you were required to save all of them. It was like all or none. So, but now, since Fixpack 1 and later, you can pick and choose, which in-memory aggregates you want to include as part of that set. So this dialog is I think it's quite nice. It's a nice tabular way of reviewing those in-memory recommendations, and you can also do some sorting here based on the name or the size or things like that. So it's lots have been done for the usability of this list of in-memory aggregates. Okay, so by default it's going to select all of them. Let's just keep all of them here. Let's say okay, we're going to apply all of them. If you remember, we did not change that limit in the cube properties for the in-memory aggregates. We left it at 0, so this is just a warning message to let you know, hey, I've estimated in-memory aggregates to be about 1.9 megs, and your maximum for your cube you set at 0. So you might want to go back into your admin before you restart the cube to increase that limit. Yeah, I know, I did on purpose. So okay, it's been stored, all good. Usually your next step here is to go into the Cube Designer and model your aggregate cube, or model and map that database aggregate into your cube model. I'm not going to go through those steps here today. Again, you can look at the last year's lab video, but I will open up the model and kind of give you a nickel tour of what that looks like. So let me open up that model. Double click on historic sales, aggregates. Okay, so I've gone into my cube, double clicked on the cube, clicked on my aggregates tab, and one thing I'll call out here is a little bit of a name change, something to make it a little bit more consistent with some of the name changes that have gone on with the rest of the product. Previously we called them aggregate cubes, and aggregate cubes are now called in-database aggregates in the UI. I mean, I've always called them in-database aggregates, and that's what they are. So why not make the the UI reflect that? So so just calling out name change in 10.2.2, aggregate cubes are now in-database aggregates. So they're here in the top portion of your pane here. I'm going to double click on that. This should look familiar for those folks that did do the lab before or seen it before. This is the database aggregate. It is, I'm selecting products. It's on that product brand, promotions, promotion name level, retailer at the region level, and time at the day level. And the measures related to that are all the measures that were recommended as part of that from DQA in the advisor recommendations. Here, all the measures here, and you can see there's mappings to. Hopefully, you can see the mouse over Agger, prod band, promotion name. The table name, the aggregate table name, is prefixed here for that column. So that's that. It's all mapped. Also, all the level keys are also mapped to the aggregate table, corresponding aggregate table columns as well. So that's all there. That's great. I'm just going to publish this cube because I already modeled it. Okay. I am going to choose to start the cube. So recall I saved the in-memory aggregates in DQA, so they're stored in the content store. They won't get loaded until I restart the cube. So what I'm going to do now is I'm going to restart the cube, but first publish the model with the database aggregate there. What it should do, is after the cube is started, start loading those in-memory aggregates and also leverage the database aggregate that's out there. Because it said it could, if you remember here, that this database aggregate would cover 4 in-memory aggregates. So let's take a look. Okay, so let's go into Cognos administration. Selecting historic sales. View recent messages. Oh, you know what? It didn't. It did not load the in-memory aggregates. Why? Because we didn't set the the maximum size for the cache from 0. That's fine. That's okay. All right. Well, we have the warning message to let us know what to do next, right? So let's go set our properties. Maximum space for in-memory aggregates. Remember, the estimate was about 1.9 megs. I'm feeling generous today. I'm just going to give it 128. Just give it a lot. Doesn't matter. Our JVM is set to 1 gig. It's more than enough. Let's move on. So I'll set it to 128. So the 128 is much more than 1.9 megs. That should be enough memory there. I usually say to wait a few moments to let the settings make its way through and everything before restarting the cube here. And then now let's do that proper restart. And hopefully now it should load the in-memory aggregates as well. So, maybe I didn't wait long enough. So, one moment please, while everything goes through. I just want to double check I set the right parameter. Maximum space for in-memory aggregates, 128. Yep, that's what I want. So if you can see on the right-hand side for the metrics, you'll see the loaded over defined in-memory aggregates. There are 4, so there are 4 in-memory aggregates in your content store that are out there, and maybe that's enough time. Let's stop that cube. Okay, you'll see the status is unavailable, show that it is stopped, and the cube state is stopped here on the right-hand side. And let's start that cube up right now. cube is available. It's running. I'm going to hit refresh here on the metrics pane, and that was really fast, super fast. I don't know if you guys saw it, but the loaded over defined is now 4 out of 4. Let's double check the recent messages here. Yes, it did. It loaded all 4 of the in-memory aggregates, and you can see here the aggregate table hit rate is 100%. So it did not lie. It is hitting, the loading of those in-memory aggregates did go and did route to those database aggregates. And because it did, it was super fast. So that's that there. Let me check my notes real quick to see if there's anything I missed, because I wanted to highlight, because I did go through a fast version of this lab. Okay, so I think in last year's lab, I think what we ended up doing then was running these reports and showing that, yay, look, it's an in-memory aggregate hit and all that. So let me just do that real quick here. We'll run this first report here. So we will rerun the original workload reports here. Remember when we ran the advisor, we captured the workload with these 3 reports and asked the advisor to recommend some aggregates that would, support what they saw in the workload. So after running these reports, we should see that it should hit, the in-memory aggregate completely. And again, my VM is running on my laptop, so I don't know what's going on, but it should be running, churning away. Okay, so that's one report. We'll go back. We're taking off right here. Yay, that one's done. That one's done too. Yay. And we're going to go back into the metrics for the cube, refresh this panel real quick, and in-memory aggregate cache hit rate here is 100%. So all those 3 reports that I just ran did hit the in-memory aggregates. Yay. All right, so there are actually a bunch of other reports that I wanted to run to show you that this isn't just a magic trick and it's not always at 100%. I'm going to run this report here. And this report should take advantage of some of the data cache values. Did it run? Great. And I'll go back here. You see the data cache hit rate is 0.03. If I refresh that, now it's 0.06. It's up, which means that, that report did hit the data cache. Awesome. And this one last report that I'll run is that region, product type on day. It's a little lower in terms of levels, and so I expect this to miss the in-memory aggregates because it's a little lower, but it should route to the database aggregate because that's at a little bit higher level than the database aggregate. So when we look at the metrics here, if I refresh, yay, the aggregate table hit rate is still 100%. And yes, I didn't lie, and it's not hard-coded to 100% all the time. The in-memory aggregate cache hit rate is 99.92% here, so that shows that. So that shows a little bit of the metrics that you can take a look at when working with your in-memory and in-database aggregates. All right, so next we're gonna let's prime some reports. Let's prime the caches. So as I mentioned earlier, cache priming, this is where you would schedule some reports to run to populate the other caches, like the result set cache, expression cache, and data cache, to kind of accelerate certain specific report performance. Usually this is done for if you have a set of reports and dashboards that your execs run or majority of the users run. So you run those immediately right after the cube starts, so that when they first come into the office and run those reports for the first time, they're super fast because they're already primed in the caches. It doesn't always have to be those reports that people always run. You can create some. You might want to create some primary reports that you might want to just populate the data cache with, because they might be more targeted, large swaths of the data that you targeted caching for instead of having a huge, ginormous in-memory aggregate. So let's say, for example, you've identified this number 1 report, region by product brand. Year month is, a very important report that you want as fast as possible. So you want to schedule that to run. And then also here under, maybe you have a primary report And really this is just a large crosstab of regions. But actually, let me show you. Let me run it. I'll show you what it is. What this really is just a large crosstab of regions by product type and all the individual days of 2014. You know, this is the primary report where we want to just get this subset of data, only the dates within 2014 into the data cache. But no one really actually runs a report that looks like this. You just want it to populate the data cache. So that's why I've kind of named it primary report. But let's say we want to schedule these two reports for by a trigger. And for that report, so for this number one report that we want really fast, we're going to go to the schedule button here under actions, the one that kind of looks like a calendar and the little clock on it. I think that's what the icon means. The spiral on the top. Okay, so then we're going to go and we're going to schedule to run by trigger. And trigger, you give it a name. I'm going to call it after load because I want it to run after the in-memory aggregates are loaded. You can give it whatever you want, but I'm going to call it after load. Click OK there. So I've done that for the number one report. Let's do that for our primary report too. Click on schedule by trigger after load. Okay. Click OK. Done and done. All right. So now we'll go back and we'll go into Cognos administration. Put that as the trigger that we want to run. So for historic sales cube, we'll go into the properties for the cube, and new for 1022 is a new trigger. So before we had a startup trigger name, you can specify this, and I'll run the trigger after the cube started. But now we have a post in-memory trigger, and this is a trigger that would run after the in-memory aggregates are done loading. So here I'm just going to set the same name that I gave there, after load. Recall that in-memory aggregates, when they're loaded in parallel after the cube is started. So really to kind of leverage the stuff that's in your in-memory aggregate cache and kind of avoid any unnecessary concurrency of running primary reports and aggregate load reports at the same time, we really recommend that you use this new post-in-memory trigger, and we're doing that. So I'm going to call it after load, click OK. And so now we need to restart the cube and verify that those reports are run. So remember, I said anytime you change any of the cube properties, except for workload logging, you have to restart the cube to have those take effect. Okay, so we're here and we're gonna restart the cube here. Hopefully that was long enough for the setting to make its way through and all that. All right, and refreshing. All right, I'm going to take a look here at the view recent messages. That was really fast. Okay, so it restarted the cube, loaded those in-memory aggregates. Let's take a look at the timestamp here, 3:29 and 48 seconds. Keep note of that. And let's take a look to see if the schedules for that trigger will run. So we're going to go here on the left-hand side under the Status tab, Schedules. Okay, so here are the different triggers that we have defined right here. So let's take a look. Actions for the primary report. We'll click here. We'll view, let's take a look at the run history for that. There's nothing here yet. It takes a little while sometimes. Sometimes it takes a few moments for it to, actually kick off the run, as well as refresh the history information that's out here. I think it's a little shy, so you know what I'm going to do? Maybe I didn't wait long enough after setting the cube properties for it to, kind of pick up. Did I spell it wrong? No, I spelled it correctly. After load. Okay, it's all there. Great. Let's stop it. And let's restart that cube one more time. Okay, let's do recent messages. All done. Now 3:31:56. Again, it might take a little while for it to kick in, but let's just take a look at it anyways. Run history. I think sometimes it takes like 30 seconds to a minute or so for it to kick up the schedules and run. So let's go back here. Ah, there it is. We threatened it by looking at the logs, so it did run, and as you can see, you could verify that by looking at the logs as well. So I think it is like a watched pot. It didn't boil. We looked away. We looked at the logs. It actually did run. Whew. Okay. So if you remember, the in-memory aggregates were done loading at 3:31. You see that this report was run at 3:32 right after that, so it should have taken advantage of the in-memory aggregates that are out in the caches, so 3:32 as well. So that's that. And let's double check the metrics to see what we see. Right, so the in-memory aggregate, the database aggregate table hit rate is still 100%. The in-memory aggregate hit rate now is 65.27%, and that's because, remember, one of those triggered reports, that priming report, that really large crosstab, that one missed the in-memory aggregate altogether, right? But it was satisfied by the database aggregates, which is why it's still 100% here, which is pretty cool. So that's that. And if we go here, go to this report, and run, let's say, this report, region, product type on day, you'll see that it should, some of the data that this report is looking for should already be in the data cache in that priming report that we ran, because this is for a specific day in 2014, September 15th, and if we go back here into the metrics, where's the data cache? Data cache is 0.03, let's refresh, and that is now higher, 0.18, yay, it hit the data cache because we primed it with that very large crosstab. Okay? Whew. I was nervous for a little bit there, but it all worked out in the end. It's just a matter of timing and being a little patient. Okay, so that's that for the cache priming portion. I'm going to now move to the user-defined in-memory aggregates portion of our program. For user-defined in-memory aggregates, as I mentioned before, really the best practice is to continue running the Aggregate Advisor to get a real full set of in-memory aggregates. But if you do know what you want in terms of in-memory aggregates and stuff, you can define them in your cube model. So let's say, for example, you've gone through all the best practices, including the stuff that we already did, like running the advisor once already. We have database aggregates in play, and we primed reports. We primed the caches with some reports. That's all good. But you know what? I kind of want another in-memory aggregate there, just because I want to. And so what do I want it at? So let's take a quick look here. Let's say I want, remember those best practices, right, of having in-memory aggregates that are backed by database aggregates, and also having some intermediate level slices in your in-memory aggregates. So let's say we want something between this product brand, promotion name, region by day, and maybe something between that and product brand, region, month. Let's say we want to create something at product brand, region, and day. So it's lower than this, but higher than that. Okay? So let's say that's what we want to do. So let's go into Cube Designer. Let's go into our Aggregates tab. This Aggregates tab now is divided into two parts. The top part shows your in-database aggregates, formerly known as aggregate cubes, to model and map any database aggregate tables you have. And then the bottom part of this panel is where you can define your user-defined in-memory aggregates. And here's a little warning message that we probably mentioned before, that user-defined in-memory aggregates can affect the performance and memory utilization of your dynamic cube. You really need to use the Aggregate Advisor to incorporate any of these user-defined in-memory aggregates into your cube. So purely just modeling it here doesn't create the in-memory aggregate for you. You still have to go through the Aggregate Advisor to apply and save your set of aggregates to your cube. Okay? So let's create a new user-defined in-memory aggregate, and let's select all the measures here they wanted. You'll see that the workflow is very similar to modeling of an in-database aggregate, but we don't have to map any of the columns to any database tables because we're just identifying those levels that we want. So what do we say? We wanted something like product, and retailer, and time. Those are the dimensions in play that we want. Okay, so we're going to create that there. I want to name it something a little better. I'm going to call it user UD Agger, and we want it at product, brand, region, and day. Okay, that's the name I want to give it. I'll double click on it. And here we'll identify the levels of aggregation. So for product, we want it at product brand, just under the product classification hierarchy. That's all we want. Under retailer, we're going to select region. Under time, we want it down at the day level. Okay, so that's that. And then let's double check the measures. Yep, those are the measures we selected. And that's it. That's it. We've identified what we wanted for our user-defined aggregate. So remember, this is just the modeling of it. This won't save it in your, it won't load it as part of your in-memory aggregates for the cube, but it is part of the model. So let's publish it. Let's just publish it. You don't need to start it or anything like that. Just need to update the cube model. Yay. That's done. Okay, so we've updated the cube model that's in the content store. Great. So now, how do you get that user-defined in-memory aggregate as well as all your other aggregates? Get it as part of the in-memory aggregate set. So you go back into DQA. For all things Aggregate Advisor and aggregate related, go to DQA. And we're going to run the Aggregate Advisor here. I'm going to launch that wizard. And click on the Historic Sales Cube, click Next. And here's just a new option for workload information. For this run, we'll just select user-defined only so that the advisor runs uses only the user-defined in-memory aggregate definition that's in the cube model. So that'll be a lot faster when it runs. So I'm just going to click Finish here to let it do its thing. So those options that say user-defined only, and also previously with the query workload information only that we did earlier, those really help to reduce the amount of time the Aggregate Advisor runs, so that it recommends only those kind of aggregates that are focused for what you want it for. So the query workload only is focused on just query workload. Choosing user-defined only will just focus on that any user-defined aggregate that you define in your model. By default, both cube structure and query workload information is selected, and really that allows the advisor to use the full breadth of information that does have like query workload as well as any kind of model analysis to get you those recommendations. I think it's worth noting here that if you have any user-defined in-memory aggregates in your cube model, no matter what option you choose on that panel, user-defined in-memory aggregates will always be part of your advisor output. Okay, so they kind of take precedence over anything else because you define them. You're the boss. You're controlling that. So anytime you have user-defined in-memory aggregates, they're always going to be part of the output. And any additional recommendations that come as part of that are, to kind of to supplement the recommendations. Okay, we want the user-defined in-memory aggregate only. All right, run that. So what the advisor does at this point, since we said user-defined only, is it'll look in the model, take a look at any user-defined aggregates that we have in the model. We have one, and what it does here now is calculate the slice cardinality of that user-defined aggregate by using some data sampling. And it uses that information to estimate the size of the in-memory aggregate when it's going to be loaded into memory here. And so what you see here is a little graph of the progress from some progress here. I think each major step is one of those in the advisor's logic where, maybe first it tries to identify what aggregates it has, tries to identify some numbers to use for data sampling, running those data sampling queries, getting that slice cardinality information, running through its calculations for estimating the size, and it's done. Okay, so it recommended one in-memory aggregate. That's what I wanted. This is what we get. So it recommended the user-defined aggregate that I wanted. It estimates the size for this as about 5.6, 5.7 megs. So let's put them all together. So apply selected in-memory aggregates. Here we have this one listed right here. And actually new in 10.2.16 Pack 3, you can select to combine any additional in-memory aggregates from other results that you might have. So you can create one master set. So what I'm going to do here is click on the Add button, Add, and I'm going to choose the results from my other result, the checkpoint result that I have from last time. And you see that I added all the 4 from last time, and I want all of them. So I'm going to do select all 5 of them and estimate the total size of my user-defined plus the 4 I had before as 7.6 megs of space needed. And if you remember, I was really generous earlier. I gave the cube properties 128, so I don't need to change anything. That should be fine. I'll click OK, and that should get saved off in the content store. And, sorry, took a little bit. No, I got saved in the content store. One thing that you'll see here is that it created another advisor result. And so this is something that was new in 10.2.16 Pack 3. Any result that you created by combining results from other results is identified here by a save to server entry. You can also rename these if you want, but just so you can come back later and say, like, what did I do on September 30th and on 3/48? Oh yeah, right, I saved 5 of these to the server, and what's in those 5? These 5. Okay, so that's all saved and stored. Let's go back to our cube, and let's restart that cube to load those 5 in-memory aggregates. As you can see here on the right-hand side, you saw the loaded over defined did change to 5. I'm going to refresh. Now it is 5 out of 5. All done. Great. Refresh real quick again. 5 out of 5. Great. Aggregate table hit rate is still 100%, meaning, remember, our user-defined in-memory aggregate did route to the database aggregate. And I'm going to scroll down real quick here in the metric, if it will let me. Used over defined in-memory aggregate cache is 5.9 out of 128. Remember, we gave it 128. It only really used 5.9 megs of that into the cache. Pretty awesome. Okay, so let's run a report. Let's run a quick report to verify any aggregate cache hit. Actually, you know what? The primary report is at region, product type, and days. And if you recall, our user-defined aggregate should be able to satisfy that. So let's run that report. And it should have been scheduled to run anyway, so let's just run it one more time. Great. Awesome. And then let's take a look at our metrics. We should see that the in-memory aggregate cache hit rate is still 100%. If you remember before when we did that without the user-defined aggregate, it was like 65 something percent. We have that user-defined aggregate that satisfies that primary report. It's 100%. It's all good. Everything's primed. Done.
I think it's a good idea to pause for questions. There's at least one question that's come up right now. If we did see that something caused a memory hit, will it help identify what caused it and how to troubleshoot?
Okay. So for troubleshooting and trying to figure out one thing here, the metrics are just numbers. It's like, oh, it's a hit, it's not a hit, and like, well, okay, that's nice, but what if it wasn't a hit? Or what if you wanted to find out a little bit more information? What exactly did it hit? You can find that information by enabling additional logging information. And the Cognos installation configuration directory is execute diagnostic logging file. And in here, under the XQE component are a bunch of event groups here. There are certain logging levels and event groups that you can enable here to identify things like, for troubleshooting, in-memory aggregate routing and database aggregate routing. You can take a look at the SQL and so forth. So I am not going to, I don't remember them all off the top of my head here. There is a DevWorks article about advanced logging and what logging levels to put out here. You can also do a Google search for this. It's the Proven Practices document, IBM Cognos Dynamic Cubes, Advanced Logging Settings. Goes through a bunch of the different logging stuff that you can do and turn on. Enable logging for performance. Seeing where the time is being spent in the query engine, whether it's in the database or routing to different aggregates. Here are different caches. You can do some more troubleshooting here. So, and here are the two other logging event groups. Aggregate strategy. This one's about the routing to the database aggregates. And here's a trace event group for the aggregate cache. And this document has a lot more information about how you can do some more troubleshooting. Hope that answers that question.